We will solve some questions related to testing of hypothesis. Okay, then first of all, read the question well. A random sample of 50 items gives the mean 6.2 and variance 10.24. Can it be regarded as drawn from a normal population with mean 5.4 at 5% level of significance? Okay, so first of all, write whatever is given. A random sample of 50 items. So it is sample number, is sample size is given as 50. Then random sample gives mean. That means x bar is 6.2 and random sample variance. Sample variance means S. S is equal to variance is 10.24. So standard deviation is under root of 10.24, which is 3.2. Okay, then we need to check, can it be regarded as drawn from a normal population with mean 5.4? So population mean mu. Mu is equal to 5.4. This is what is given, and alpha is equal to 5%. Okay, so first of all, as I told earlier, first of all here we need to define some null hypothesis and alternate hypothesis, then we will test. So null hypothesis H naught is equal to is mu is equal to 5.4. Always we will check that the population mean is same as the sample mean or not. So H naught is mu equal to 5.4. Then alternate hypothesis. Alternate hypothesis, you can use both the terms. HA is mu not equal to 5.4. Okay, now this is right tail, left tail or two tail test you can use here. So I am taking the two tail test. So now that is defined. Now second step here is we will find the test statistic. Okay, test statistics. Now yesterday in the previous lecture we told how will you decide the test statistics. Okay, now here if you remember that one, yesterday we discussed that if the sample size is greater than or equal to 30, we use Z test if population standard deviation is known. But here the population standard deviation is unknown, so we will use this one. So you will use Z test only, but instead of sigma, there you will use the letter S. Okay, so that is what we are going to use. The test statistics is Z is equal to x bar minus mu upon S divided by root of n. Its modulus value you will take, because we take that to the right and left of this, 0 to this side and 0 to right side. So both negative positive comes, so we will take that Z lies between these two values, so we will take this. Okay, then therefore Z is equal to x bar means 6.2 minus mu 5.4 divided by S. S is 3.2 divided by root of n. Root of n means 50. So on simplifying this, you will get the answer as 1.77. Okay, so that is a test statistic. Now third step is LOS, level of significance. So here the level of significance is given as 5%. So I will take alpha is 5% or means 0.05. If it is not given, that is, it is your option to choose that one. You can choose 10, 5 or 1 level of significance, but as a general case, it's better to use 5% level of significance always. Okay, then so that is, then fourth one is critical value. Critical value means value of Z at 5% level of significance. So that we use the letter Z alpha. Z alpha, again this I have given you the table yesterday, that is when alpha is 5%, this when alpha is 5%, what is the value of Z? Z is given as 1.96. Okay, so that is Z alpha is 1.96 at 5% LOS. Okay. Then fifth one, now we will decide what we are going to do, means whether we accept the null hypothesis or we reject the null hypothesis. So decision means, now here this Z means this is the calculated Z calculated is 1.77. Now decision is like that, if the calculated value is less than the table value. Okay, so here we will write, since Z alpha is less than, Z calculated value is less than Z alpha, we accept H0. That means if you consider a curve here, Z alpha is 1.96 here. Okay, and Z calculated value is 1.77, that is before this 1.96, that comes to this part. So this is the region of rejection. If the value comes here, if the calculated value comes below this value and above this value, means more than 1.96 and less than 1.96, then you will reject that one. Now here the calculated value is less than 1.96, means it came before this 1.96. Okay, so here we accept the null hypothesis. Okay, so always it is like that, if the calculated value is less than the table value, you accept the hypothesis, and if the calculated value is more than the table value, then we reject the null hypothesis. So here this hypothesis is accepted, therefore the sample is drawn from the population with mean 5.4. How will you write that statement? Look at the last line of the question. Can it be regarded as drawn from a normal population with mean 5.4? So the sample is drawn from a population with mean 5.4. So this is your first question. Okay, so this is the way to solve or test the hypothesis. Now let's do another question, that is a random sample of 400 members is found to have mean of 4.45. So let's see, random sample of 400 members. So what is given there? Sample size n equal to 400 is found to have a mean of 4.45, means sample mean means x bar is 4.45. Okay, now can it be reasonably regarded as a sample from a large population whose mean is 5 centimeters? So population means mu is equal to 5, and population variance means sigma square is 4, therefore sigma is under root of 4, that is 2. Okay, so that is given. Now the question is, can it be reasonably regarded as a sample from a large population? So null hypothesis we will assume as null hypothesis H0 is mu is equal to 5, and alternate hypothesis HA, that is mu not equal to 5. Okay, then now second is, we will see test statistics. So like in the previous question, what is test statistic? What will be it? So it is x bar minus mu divided by, here sigma is known, population standard deviation is known, so you will use sigma upon root of n. If the population standard deviation is not known, and if the standard deviation of sample is known, sample S is known, and if the number of samples is large, then there, like in the previous question, instead of sigma we use there S, because n was large and sample standard deviation was known, population standard deviation was unknown. Okay, so here z is x bar minus mu upon sigma by root of n, that is x bar 4.45 minus 5 divided by 2 divided by root of 400. So on calculation you will get this as 5.5. So this is z calculated value. Better to write this because later you will not be confused. Now 3, that is the level of significance. Now in this one, level of significance is not given in the question. Okay, so I will choose level of significance alpha is equal to say 5%. 5% means 0.05. Okay, then corresponding critical value. So critical value at 5% level of significance is 1.96. So at alpha equal to 5%. Then fifth one, decision. Now what decision and conclusion you will take? So decision is z calculated value. This z calculated value is 5.5. This is very much greater than z alpha. Okay, means if you consider the curve, so here this is 1.96 is z alpha is here, and calculated value is 5.5 is somewhere here. After this means after this, that comes in the region of rejection. 5.5 means it is again after 1.96 you can plot 5.5. Okay, so 5.5 comes here somewhere. Okay, after 1.96 means it comes in the critical region, so obviously we will reject the null hypothesis. So here that calculated is greater than the table value, therefore we reject the null hypothesis. So we reject the null hypothesis. That is, what statement you will write? Here the question is, can it be reasonably regarded as a sample from a large population? So the sample is not drawn from the given population. Okay, so this is a way to test hypothesis. Now let's do one more question. Third question is, a machine is claimed to produce nails of mean length 5 cm and standard deviation 0.45. A random sample of 100 nails gave 5.1 as their average length. Does the performance of the machine justify the claim? Okay, so here machine is claimed to produce nails of mean length. So when machine produces nails, that will be the population. Okay, so this what is it is given. This mean is the population mean and standard deviation is the population standard deviation. Okay, so what is given? Mean of the population, that means mu is given as 5 and standard deviation of the population, that means sigma is given as 0.45. Now a random sample of 100 nails, n equal to 100, is a random sample of 100 nails gave 5.1 as their average length. So sample mean means x bar is given as 5.1. Now the question is, does the performance of the machine justify the claim? So to test that one, assume the null hypothesis. So null hypothesis H0, that is mu is equal to 5, and alternate hypothesis HA is mu not equal to 5. Okay. Then second, test statistic. Test statistic. So here again what is given? Sigma is known. So we will use x bar minus mu upon sigma divided by root of n. This is the test statistic. So that is z is equal to 5.1 minus 5 divided by 0.45 divided by root of 100. On simplifying this, you will get 2.22. Okay, so now the level of significance. So nothing is given as level of significance, so I'll choose it as alpha is 5% level of significance. So corresponding critical value. Critical value means critical value Z alpha is 1.96 at 5% level of significance. So whenever you take the null hypothesis and alternate hypothesis like this, not equal to, so always you will take Z alpha as 1.96 at 5% level of significance. Now 5, what will be the decision? Okay, now here Z calculated value is greater than Z table value. So calculated value is 2.22, which is greater than 1.96, means if you draw this one, so 1.96 is here and these two are the rejection region. 2.22 means it comes after 1.96, so that is in the rejection region, so obviously we reject the hypothesis. Therefore hypothesis or null, we reject the hypothesis. Reject the null hypothesis. Okay, therefore final statement, decision, conclusion you can give: performance of the machine doesn't justify the claim. Okay, so this is the way to test hypothesis.